Hi guys. So today we're doing 1.4b reflections, strengths, and stretches. Um, you should have this classwork in front of you. It starts with video notes and then kind of works its way down some graphs. And that's what we're doing today. So take a second to go make sure you go get that worksheet, and then we'll start the video back up. So the video today is kind of going to be mostly on your own, but we'll do this warm up. Obviously, part D you don't have to do for the answer pad. I'm not there, so you can't do it. But I want you to graph these three and then just kind of figure out what you notice. Just take a second. You can pause the video, do those, and then restart the video when you're done. And what you should have found was they're obviously all V-shapes. They're all absolute value graphs. This one's shifted to the left 4, which is what we did last class. This one has a reflection over the y-axis, but first it's shifted to the left 4. And this one just reflects graph A over the x-axis. So all the y values change. All right, so today we're going to do a video. It's on Schoology, so I'm not going to play the video within the video. Go to Schoology, click on 1.4b, shrinks and stretches, something named like that, but it's a video. It's a long video. I want you to stop once you hit 14 minutes and 36 seconds. And, take about 25 minutes to do that. So you can pause, rewind, take notes, do all that stuff. It's an important video. It kind of goes through all the stuff that you're going to deal with coming up in the slides. So make sure you kind of understand that stuff, and we'll go from there. Okay, so we're going to be working with all the translations and all shrinks and all stretches and reflections in once. So there's an order that's going to work when you graph them, and that's the order. So first is going to be horizontal shifts, then stretches, compressions, then reflections over the y, then over the x, and then the last one is the vertical shifts. The key one here is horizontal shifts actually do start it, and vertical shifts do end it, which might not make sense, but it does work. The classwork that you have may give 3 other ones. They might not be in the right order. I'm not sure if these got printed on the new one. The honors course, we only deal with 3, but you guys will have to deal with all 5. So this first one we have like 1/3 and then negative x plus 2 minus 5. So first thing you would do is actually move left. So if you wanted to do a chart of values, you would shift all of your x values left 2. Right? So -2 would become -4, so on and so forth. And then after that, we would do our stretch, or shrink, which in this case is actually a shrink or a compression. They mean the same thing. So 1/3 would be a vertical compression or vertical shrink by a factor of 3. If you say by a factor of 1/3, that's fine. It's really kind of the same thing. And then the next one we would do, we don't have to worry about a reflection over the x-axis, but the next one is over the y-axis, which the negative on the inside does mean. The negative on the outside means it's going to reflect over the x-axis, but on the inside it's the y-axis. And just keep in mind, when it's reflecting over the y-axis, it's the x values that are changing. So all of your x values, now that you've changed them left 2, you're going to make them all the opposite in your chart. And then what you would do last would be the vertical shift, which in this case would just be down 5. So that would be the order that you would want to do them on your chart, and then even on the graphs too. So we'll go through a couple of these. So basically what I have is different transformations with each parent function. So the constant function, don't really worry about. You could have f of x equals 3 and then do 3 minus 5, like a vertical shift down 5, but it means pretty obviously you get f of x equals -2. Not something you're going to have on tests. You're more going to deal with the other types of parent functions. Even the identity function, which is just that straight diagonal line y equals x. We can give you 1/2 x, which would just be technically a vertical compression by 1/2, which just means it would get less vertical, right? Your slope would be 1/2 instead of 1. But again, it's more, not really one of the parent functions we're going to work a lot with. 5x minus 3, you could say that's a vertical stretch by 5 and then down 3. So, again, just to show you if you wanted to graph it, that's the parent, or close. And then a vertical stretch of 5, would make it more vertical by a factor of 5. And then it would also shift down 3. So, you should have something that kind of looks like that in the long run. Again, don't really worry about it too much. We're going to be dealing with more of these types of functions. So absolute value, right? You have your parent function, which is just the absolute value of x. Right, looks something kind of like that. So we could take our chart, right, and you kind of want to get in the habit of doing charts with these, right? You got -2, -1, 0, 1, 2, and then so these are my x's, these are my y's, and then the absolute value of -2 is 2, 1, 0, 1, 2. So now when we do these transformations, right, -3 x, absolute value of -3x. Right, well, first things first, we do horizontal shifts, but there are none. So the next thing we would want to do would be this horizontal compression by 3. Ignore the negative that comes next. So what does that mean? Well, it means all of your x values are going to be compressed by a factor of 3. So now I'll do this one in red. So you're going to get x and y over here. So now instead of -2, we're going to multiply that by a factor of 1/3. So you get -2/3, right? And then the 2 hasn't changed. Right? All the y values are not changing because it's a horizontal compression. It has nothing to do with the vertical or up and down. So these are all the same, but all of these are going to be multiplied by 1/3. So then you're going to have -1/3, 0 still 0. You're going to get 1 times 1/3, which is +1/3, and then last one's 2/3, right? So what we have here is the absolute value of 3x. Now we do the negative, which it's on the inside. So what that means is when it's on the inside is it's actually a reflection over the y-axis here. So all of the x values are going to come the opposite. So what I'm going to do is just to kind of show it, the opposite of -2/3 is +2/3. The opposite of -1/3 is +1/3. And then I'm going to make this one negative and this one negative. Now, since the y values kind of are the same, it was -2/3 2 and it was +2/3 2. Now this one's -2/3 2, this one's positive. It's actually not going to change what the graph looks like at all. This is what we call an even function. But I mean, at least for the chart it helps. So that would be your final graph, right? You have 2/3, 2, 1/3, 1, 0, 0, and then you got these 2 points as well, right? So you can kind of see it being horizontally compressed, right? It's really the same thing as being vertically stretched, getting more vertical, but at least this way you can kind of see from here it's being compressed horizontally, or left and right. So I want you to try and do this one on your own on your graph paper, and then do the order in the correct one. So here would be the shift, horizontal shift first, horizontal stretch second, and then up 2. But again, get used to working with a table and going through the table, and then you can even graph all of them separately. Just make it obvious which graph is your final, and that's where the colored pencils can kind of come into play. If you wanted to color code them, that's probably the best thing to do. So take a minute, do this one, and then we'll keep going. All right, so hopefully you have finished this one. I'll try and post this one on the completed notes when you're done, but I'm going to move over to square roots. So you guys know what the square root looks like. You got 1, 1, you got 4, 2, you got 9, 3, right? And that's our square root of x. So let's just go for the hard one first here. But first what we want to do is make a table of values with the parent. And do you have to do this? No, but at least when you do all the transformations, it's easier to keep them organized and go methodically. You can do a couple transformations in one chart, so you're not making 4 different charts if you have 4 transformations going on. It's totally up to you guys, however you guys think. But for the parent function, we got 0, 0. We got 1, 1. We got 4, 2, and we got 9, 3. So the first thing you're probably seeing is this +4, so that means to the left of 4. So what I'm going to do is I'm just going to move all of these points left 4. So 0 becomes -4. 1 becomes -3. 4 becomes 0. And 9 is going to become 5. So those are my new x coordinates. The next thing you're probably going to see is this vertical shift. So what I'm going to do is I'm going to and this they did it in the video. I'm just going to do it off to the right here, and I'll put 4y, right, just to say that I'm basically multiplying all my y's by 4 because it's a vertical shift. So 0 is still 0. 1 times 4 is 4. 2 times 4 is 8. And my 3 times 4 is going to be 12. Right? So that takes care of this one. I already did the shift. The only thing I need to do now is just go up 4. So again, I can even do another column off to the right here. Just to say, so since it's going up 4, I'm going to add 4 to all my y values. So 0 becomes 4, 4 is 8, 8 is 12, and 12 becomes 16. So these are my x's, the ones that I did over here, and these are my y's. Right, so now all you can do is just plot those. You didn't even have to make graphs along the way. But again, if you're more visual, you can graph each step along the way. So you could have graphed, -4 is 0, and then graph the y's with the green, and then finally do the purple. It's totally up to you. I'm probably somebody who can, do it in a chart. It doesn't really bother me. So I'll just graph the final one. But if you're somebody who likes to graph, maybe this one in the green with the y's and the x's, and then just take the whole graph and move it up 4, right? So whoops, that's not what I want to do. But if I wanted to take this and literally just shift it up 4 to do that last transformation, you can totally do that too, and just change them on the graph. But I'll do them on the chart. So my final graph, which is not going to fit, at least the 16 is not going to fit, but I'll have -4, 4, -4, 4, right? -3, 8, -3, 8. Then this was 0, 12, 0, 12. And then the 5, 16 is just not going to fit. But that's what your graph should look like, something like that. And as you can kind of see, it is a vertical stretch. It's definitely being stretched vertically, right? The +4 means left 4. The +4 at the end means up 4. You're definitely left 4, up 4, and stretched vertically. It's a quick check that you can do to make sure you did it right. All right, next one, quadratics. Again, I'm going to just skip this 3x squared one. We'll go right to this one. And don't panic if you see this. That just means you can simply move it over this way. And now it's in your standard form there, so you can work with it. Actually, vertex form. So actually, I'm going to have you guys try this one on your own. And so you can pause the video and try this one on your own and see what you come up with. And hopefully you came up with something that's a little bit wider than your parent, right? You got the 2/3. You should be shifted to the right 6 and up 3, so it should be starting over there. And the 2/3 was basically the same thing I said. It's a vertical shrink because it's less than 1, but between 0 and 1. And there's no reflection, so it should be something that's a little bit wider than the parent. I'm not sure if any of those points are right on, but it should be pretty close. This one, let me see what we have here. We have our cubic. I'm just going to scroll ahead, and then the reciprocal. The cubic one here, again, you can start with your parent function. You got -2, -8, -1, -1, 1, 1, and 2, 8. So, you'll look something like that, close enough. So there's the parent function and a couple of points. And you always want to try and do 5 points, unless it's a square root and it doesn't fit. 4 is probably okay. But these ones we can do -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. So here when we go with this one, what we're going to do first is this left one. So all of my x's are going to go to the left one. So it's going to be -3, -2, -1, 0, and 1. So that takes care of that one. The next thing I want to do is the reflection over our x-axis. So all the y's are going to change. And I'm just going to make this +8, +1, -0, I guess. -1, -8, and that takes care of the negative on the outside. Again, reflecting over the x-axis, the y values are the ones that actually change. And then +1/4, so I can just go, okay, well, that's just going to be 8 1/4. right? Now it's just going to be 1 and 1/4. And this one's just going to be 1/4. Negative 1 plus 1/4 is going to be negative 3/4. And negative 8 plus 1/4 would be 7, or negative 7 and 3/4. So that's really all that you need to do. Now you just need to graph it and use these as your x's and these blue ones, well, with the purple as your y's. So you got negative 3, 8 and 1/4, right about there. Negative 2, 1 and 1/4. You got negative 1, 1/4, 0, negative 3/4, and 1, negative 7 and 3/4. So again, you'll notice you keep the same shape. It's still definitely a cubic function. That will never change. It's just a matter of where it's going. So here there was no shrinks or stretches, so it should be exactly the same width as the purple one, in which it is.